So when we talk about stock and waste management, as the guest lecturer has mentioned, excessive inventory actually is a problem in many, for many retailers or especially supermarkets, when they actually store thousands of SKUs. And so here we introduce a couple of very simple method or decision rules in order to help to reduce excessive inventories. So the excess inventories can be the dead stocks. So in the long time, the product has been stored in the warehouse in the shop very long time, but doesn't really move. In the investigation, the evidence shows there is 47% of stocked items actually have not been sold in the past 52 weeks. That's actually a very significant level. Cal, our guest lecturer, also mentioned this is a serious problem for selling group. So what's the reasons of the excess stock? So now that must be many different reasons. For example, replenishment error. So you actually ordered too much, or the bad forecasting, and then or the bad deals from the buyer in order to achieve the quantity discount, all kinds of reasons. And then once the excess stock existed, so how can we actually deal with the situation? So here we see the different solutions, could identify the associated items, decide on what remedial action to take. So in our textbook, in the section 8.6, you can actually see more explanations about how to reduce excess inventories. So here in this in our course, we just mention two specific situations. So first, we look at how to identify the really slow-moving or dead stocks or excess stocks. Here is a book example about 200 items. So in order to review the stock status, so we can see we start by collect the information about the on-hand inventory. So here we call it I, small I. So it's on-hand inventory. Basically, this is just counting. Just count how many units of the items stocked. And then we have the information about demand. So this can be counted at the annual level. So here we talk about units per year. So now we can see for some items actually have never sold anything, at least in the past of year. And then some items, so for example, item 5, 6, 7, you can see they are relatively small sales. And then in the bottom, you can see there are large sales. And then we also collect the information about the individual values of different items. So the DBV curve, we also actually used distribution by value, also used in the ABC analysis. So hopefully you still remember how to do that. So here we do not calculate demand times value. Here we're actually more interested in the inventory times value. So here in this column, you can see we calculate I on-hand inventory times the value of each unit. Then you know these are the value, stock value. of these items. And then we also calculate a value called the coverage. So what is coverage? On the bottom of this table, you can see we have a formula to calculate the coverage. So this CO coverage means the months of your inventory hold. So for example, we talk about how long time this inventory can be used to satisfy the demand. So here, for example, if you have never sold anything last year, then we actually get a infinite coverage of this item. And then we can see the item 5. So here the coverage is 318 months. Then how did we get this value? Then we use 12 times II for this item, which is 53 units, divided by the demand for this item per year actually is 2 units. So that's how we get 318 months. So this 53 is inventory divided by your yearly demand 2. Then you basically can hold this inventory to satisfy the demand for about 26.5 years. And then each year is 12 months. So that's why we got 319 months. Similarly, you can see the other calculations. Now we have the coverage in months and the storage value. Then we can calculate the accumulated percentage of your inventory value across these 200 items. So here the dollar values. So in dollars, actually, it's calculated by the. So this is the sigma. If we can see, this is the sum of I and VI. So 270 is for first item. 300 is the first item plus 30 from the second item. So then you actually get these values. So that's how we calculate accumulated storage values. And then the percentage you can see in the top, the very slow moving items actually occupy your capitals, assets. So once you actually identified this very slow moving or excess inventories, so for example in this case we can look into the first 7 items, then to investigate even the first 10 items, and look into it's possible to reduce some of the inventories. So before today we actually talk about how to accurately forecast the demand, how should we actually manage the inventory to reduce the cost, to satisfy customers' service level, at the same time do not actually cause excess inventory. But once the excess inventory incurred in your storage or in your business, then you have to think about regularly check the inventory and remove or reduce the excess inventory. Here we are talking about different rules to actually dispose the excess inventories. As we know, if your inventory stay in the warehouse, nobody probably ever noticed that, but they still stay in your financial report or business performance as your asset, but that doesn't really create any value for your business. So if you could identify the excess inventory as early as possible and dispose them, you probably can still achieve some value. So you could think about the longer you hold the inventory, the less opportunity you can actually realize any value from those long time old inventories. So here we're talking about a rule for disposal decisions. Then we have two different rules. The first rule we're talking about disposal decisions when you actually have a deterministic demand. So here we're talking about we know the demand for sure. We actually skip the derivation, mathematical derivation part. The idea actually is to reduce the excess inventory so that you can actually reduce the waste. So in the appendix of our textbook, you actually can see the detailed arguments and proof about how do we actually get the formula here in order to calculate the amount of stock to dispose. So let's see, we use capital W to denote the amount of stock to dispose. And then we have this formula. So here we have I is the current inventory level of the item, EOQ is economic order quantity, and G is the salvage value. So all the other parameters we have actually met before, but this G is the salvage value. We do not actually often see that in our inventory models. So here we actually consider a positive salvage value. We think about before you lost the product value completely, if you could actually give this item to different places or different purpose, you actually may achieve some small part of your value. So here we're talking about if you give the item to the outlet to sell this product with discount, all these values actually may be smaller than V. So here we actually assume this G is greater than 0 and less than V. Then this called actually dispose. This formula actually shows you use your current inventory I minus your order quantity, and then minus the demand, which actually determined by the ratio between your loss of salvage. So if you salvage, so V minus G, you can see this value is you actually give away this item with a loss of V minus G. And then the ratio between V minus G and VR, the holding cost, actually determines how many items you should actually hold. So we do not actually require you to be able to derive this formula, but it would be nice you can use this formula or understand this formula. Now we can use one example to show you how do we do the calculations. So if we know the annual demand, capital D, and the fixed ordering cost A, and the value, unit value of your item, and the holding cost, the salvage value, and the current inventory levels, then we can calculate the capital W, which is 521 units. So in total, you have 1020 units. After using this formula, you can know we know the demand is deterministic. So we actually dispose 521 units. The rest you still hold that. So this is a rule for the deterministic demand situation. Next, we see another rule for dispose inventories. So here we look into the very slow-moving items. So you can see for this example, we have a demand of 20 units per year. So it's very slow-moving, and we also assume there's a probabilistic demand, or we call it stochastic demand. So here we assume a Poisson distribution demand. Then we have a formula here in this equation. The first part, this actually shows the units of the items you should actually keep in the stock. So in this formula, you can see we consider two values. So one is a current salvage value, and one is the ultimate salvage value. So this actually determines if you should salvage the item now or in the future. So this rule tells what is the largest this formula actually gives the largest integer, which is the number you should still hold in the inventory. In other words, the rest of the items should be disposed. So for example, in this example, we have the parameters given on the left-hand side, and we calculate this value, then we got a 24 units should be kept. And then if your inventory is more than 24 units, of course the rest of the stock should be disposed. Actually, how many units to dispose is not really a challenge. So the most important problem is the company should be aware of the excess inventory or stock, and then have the best way to actually dispose the excess stocks. For example, here this list shows the options for disposing. Then we can see, for example, use for other purpose. That's actually already applied in practice. So you can see the bread or the products will be expired, normally give to charity or the poor people and so on. And then the shipment of the material to another location. So if the products are stored in a different region, different locations, then probably it's also interesting to see if the item has been sold better in other locations, then you can actually manage a transshipment. The third, we can see the use of stock for promotional purpose. So for example, you like the selling or big supermarkets would like to attract more customer flow, then you could use some excess stocked items to actually do a very large markdown, then help to promote other products or sales. The fourth, markdowns or special sales. So that's also the very commonly used method. When you ordered too much, of course you have to mark down as early as possible in order to actually get the product sold. The fifth, returns to suppliers at a unit value, likely lower than the initial acquisition cost. So that's actually, sometimes we call it a buyback contract. So if the suppliers would like to take the products back for the lower return of the cost, so that would also be considered. And then the auctions, it's also possible you send the products to the auctions, to the other sales channels. Disposal for scrap value. So that's also you can send the products to some recycling or reuse, at least get partial of the value back for material or for other reasons. Textbook has more examples for you to see them. So this is what I want to see about how to reducing excess stock. However, the most important part is actually regularly review the items in the stock and make sure there are not much excess stock.